Okay, we will begin with 2013. Here it is, 2013, where you can use the calculator. I'll begin with the problem number 76. Please open your packet 2013 and let's see what's the question here, okay? Now, this question is about a function is given piecewise, let's read the question. The graph of the function f is given, consists of two lines and a semicircle. G is defined by like this. Look at this G here. So we have Gx is given as, so Gx is given to 0 to x, ft dt, and this is the graph of f. This is the graph, this actually is graph of f. Okay. Question is, what is the value of g of 5? So if I want to find the value of g of 5, let me find g of 5, I'll replace x by 0 to 5. That means I need to find what does integral means? Area below the curve f. So this is a graph and it is from 0 to 5. So I have two parts here. First is I will find the area below the curve now from 0 to 1 and then 1 to 5. Okay, so let's do quickly. This one is the first one is a triangle. So this will be 1 and the height is 2. So area below the curve and the semicircle. So you have a triangle plus a semicircle. So area of a triangle is half. Base is 1 times the height is 3. Okay. Plus now semicircle is circle. If this was whole circle is pi r square, and the radius here, this is the radius, which is 2, because 5 minus 3 is 2, so 2 square, and because it's a semicircle, divide by 2, and that's what you're going to work on, which is 3 by 2 plus this will be 2 crosses out and you get 2 pi. And do I have this answer? You look at this is 1.5. So 3 over 2 is very similar to here because 3 over 2 is 1.5. So even if the question is confusing, this g is the area function. This is called area function. Okay, and fx is the derivative function of the area. So main original function is the area function. So if you take the derivative, it is the fx, which is given. So this one is fx, which is actually the derivative of g, the accumulative area function. So I hope I made sense. Go through this, read this. I'm sure you will get it. Let's take another one. Next one is, okay. Now what is this one is, read the question for 2 minutes. There is a volume, sphere looks this way. This is how it looks like. There is a radius here. And the volume, so this is like a sphere, it's shrinking. Its volume is getting decreased. So this is R, let's say R is the radius and V is the volume. So let's see what information is given is the volume is decreasing at a constant rate, that means the derivative of the volume per second square. So let's write this. That means I'll write dV by dt is rate minus, because it is decreasing, it is minus 3 cubic centimeters per second. So that's dV by dt. And also at the instant when t is, radius of the sphere is decreasing at a rate of I think I can't see that what is given to you. Let me check. At the instant when the radius of the sphere is decreasing at the rate of 0.25, now let me use a green color. The radius of this part is decreasing at the rate of, so here you are given dr by dt. So how does the radius, this radius is getting decreased, is given to you by minus 0.25 centimeters per second square per second, sorry, every second. So it's getting reduced by 0.25 centimeters. What is the radius? Question is, what is the radius of the sphere? Now what I'm going to do is show this work on the other side, the right side. How does it work is, let me show here, make clearly the calculations. What are the markers? So V is given, here volume of a sphere is given by formula 4 over 3 pi r cube. So now you have to take the derivative with respect to t time. So this will become dv by dt equals 4 over 3 stays the same, pi. Now this is a cube. Remember, r also is function of time. So that means r depends on the time also. So you have to take the derivative of this also. It becomes 3 times r cube. 3 reduces by 1, which is 2, and then again dr by dt. Now dv by dt plug in from here is minus 3, and this 3 cross out, 4 pi. R square is given to you here. Oh, we are supposed to figure out what is r square, stays the same, and dr by dt is here. Minus 0.25, so minus 0.25 here. So 2 minus, you can see this minus changes to plus. 4 times this 0.25 will give you 1. You can check that. That will give you as a 1. So what I used to do is, because this whole thing is like your 1 over 4, so 4 crosses out, you get plus 3 equals pi r square divided by pi, and you get r is e squared of 3 over 5. And then use the calculator. So with the help of calculator, you will see that the answer is, using the calculator, you end up getting 0.977. Okay, so just go through it again. Exactly how did I do? Started with whatever the volume, at what rate the volume is decreasing, at what rate the radius is decreasing. So if the question is, what is the radius? What is the radius at that time when that happens? So take note of this. Let's go to the next one. I hope I made sense to you for this example. Let's go to the other side. Next page is, oh yeah, it is this one. Let's do it right here. Okay, this one we did today itself. We had done one problem of this kind. Remember, you're given something like this part is confused. You see 3 to 10, fx minus gx is 2, but there is fx minus gx also. But this is not. This is 3 to 10. Let me make it a little bigger. Okay. Okay, this fx minus gx. So what I'm going to do is, what is the value of this? So I'll, sorry. So let's take this part here. I'll start it right here. So I'm going to begin with Since there is a 10, so I'll say from 0, instead of going from 0 to 3, so I'll go from that equals 0 to 10 fx minus gx, and then from 10 to 3. And we have seen this earlier, how why it is. Okay. Now, since you are given from 0 to 3, so I started from 0 to 10 and then 10 to 3. But I want to observe it. Is this same thing here? Except this is 3 to 10 and this is 10 to 3. So what's going on is, if I replace this from 3 and this becomes 10, what's going to happen is this becomes minus 2. So this whole thing is minus 2. Just check what I did. So because it was 3 to 10, I changed it to 10 to 3, so this becomes minus 2, so that becomes minus 2. Now this you separate the integral 0 to 10 of fx and 0 to 10 of gx. Okay, and this answer we already know. Now 0 to 10 is here. This goes right here, which is 21 minus, now be careful here, this is gx, but there is a half gx. So what I'm going to do is, I'm going to multiply half here and multiply 2 like this. And that answer is given, if the problem is 8. So what I'm going to do is minus this 2, this black 2 will be here. And this integral of half gx is, this goes right here. So which is given to you as 16, I believe. Correct? I made a slight mistake here. Is it given you? Sorry, it's 8. This is 8, right? And then there's a minus 2. So if you work on this 21 minus all this, you end up getting answer as A 3. So we already did today also in one 2014 questions. We have seen one problem similar kind. Always they ask the same kind of problem but written in a different forms. Okay. Next problem. This is 79. Look at this figure. Okay. Oh, make it bigger. So you have 4 figures are given there. Let's see what is the meaning of. The figure above shows the derivative f prime. So this f prime is given. Okay, the derivative of f. So this one is the derivative function of the original. So we don't know which one. One of them is the original. So we have to know which one is the right one. Okay. The trick lies is like this. First, always look up for maximum and minimum. So see, when you want to take assume these are the original functions, and if you want to draw tangents at the tips, this tips, it's always derivative is 0. So we have to see in this example in which cases the tangent is 0, the graph crosses the x-axis. And you see this crosses x-axis at 2 and 3. So that means when it crosses, this is a derivative function. So f dash of 2 is 0, but this side it is above the axis, so it is plus and it is minus here. So that means this one is like a local maximum. It means the graph has to, at this point, the graph has to be something like this. Now, when you near 3, below 3 is minus and above 3 is plus. So that means something like this. So that means here, this is local minimum. Okay. So what that means in both 4 graphs we have to see which one gives you one local maximum and one local minimum. So this is local maximum. If you see this, in this case, there are three tangents. So this is maximum, minimum, maximum. So there are three of them. So this cannot be the option. Same thing. This cannot be the option. Now I want you to think of the bottom part. If you look at this one, see this 1, 2, 3. So that also cannot be. So only option left are either C and D. So let me check for it. Okay, here it is. Now which one? So options are C and D. So which is the right option here is, I want to look up for this. Let's see. If you look at this, if I draw the derivative here, look at this. If I draw derivative here, the derivative goes on increasing, right? So till here, and then it go decrease. So this place 100, there is a 0. At 3 it is 0. Same thing here. This is 0 and at 3 is 0. So both things looks like both are right, kind of thing. Look at this point. So both are at 2 and 3. But the question is, how do we know which one is the right one? And you will see, if you try to draw a tangent in this case here, it's like negative. And the same thing, if you draw a tangent, it's negative. So the graph is below 2 to 3. So it looks like everything is it looks like both are right. But which is the right one is, just watch this. What does this? Derivative increases until 1, and then the derivative decreases till here 2.5. Just look at this point. Okay, now what I'm trying to say, one more thing, there is a point of inflections. What are point of inflection where there are loops are there? Look at this, the derivative graph. There is loop at 1, there is loop at 2.5, and there is a loop at, this is at, so 3 loops. So at this loop 1, then at 2.5, and there is 3.5 also, there is a loop. What does that mean is, so I'll just mark, let's check here. So at 1, at 2.5, and at 3.5. What it means is, your graph is concave up from here to here, then it is concave down till here, then it is concave up, and then it is goes down. And you will see this here, the derivative is positive. So if I take the derivative of this here, it is positive until 2. So if you see the derivative is positive, if you draw tangents, it's positive, then till 3 is negative. This is negative, and then again positive. So main thing is, looks still confusing, and finally you don't see that. See this, this is the point of inflection where determines like the concave up, concave down, but you don't have this here. Do you see this? You don't see that. But at 1 you have to have there is a change of concave up and concave down. Then at 2 also there should be, at 2.5 there should be concave down and then concave up. So you don't see this here happening. And one more thing you can decide is, here, if I draw a tangent here, the derivatives are decreasing like that. But if I draw tangents here and here, they go increasing. And you can clearly see this, this derivative's slopes are increasing, and therefore you can see clearly happens. So it's not like if you want to graph this one, the derivative of this graph will be, the slopes are decreasing. Let's say this was 1, If this was 1, let's say 1 is here, then the graph should have been like this. So that's like kind of confusing, but I hope I made sense with this point of inflections where there's concave up, concave down, concave up, because the 3 places that's happening. Because here it is, this is 0, f dash of s is 0, this is also f dash of f is 0, and this is f dash second derivative is 0 to know that they are point of inflections, and where you can see that this side it is, you can see it is, if you want to check here, the slope is plus and the slope is minus. So this side is plus means concave up, minus means concave down. Again I repeat, if you draw a slope here, if you draw a tangent, the slopes are positive. It means it is concave up. The green color. This is where that I think I messed up. What I'm saying is why this is concave up is, if you draw a tangent anywhere here, this graph, if you draw a tangent, it's positive, so concave up, you see like this. If you draw a tangent from here to here, so this until 2.5, to this, you draw a tangent and it is negative, so concave down until 2.5. Then from here to here it is 2.5. Concave up until 3.5. I hope I made sense to you. Even I spent a lot of time here. Finally, what I'm trying to say is, if such cases, first look up where the derivative function crosses the x-axis, which is 2, 3. That way you know these are the only options. And then to know exactly which is the right one, you could even think of concave up, concave down the way I showed. Where the second derivative is positive. So this, you look at second derivative positive means concave up, and you can see that's happening. Here the second derivative negative means the concave down, and here the another second derivative is positive, so concave up. And if you draw a tangent here, so that this satisfies all the condition there. Okay, I hope I made sense. Please go through this. Any question is there, ask me. I know I did not going through fast, but I believe if you go through again and again what I'm saying, that you'll get it. Little efforts is needed.